Summer 2027. In the heat of the Middle Eastern afternoon, a British Type 45 destroyer vigilantly patrols the volatile waters of the Gulf of Aden off the coast of Yemen. Cutting through the waves on its bold mission to protect friendly merchant ships from vicious attacks by Houthi Islamist insurgents, this Royal Navy vessel has a brand new state-of-the-art secret weapon on board, the DragonFire laser-directed energy system. Like something from a science fiction movie, this futuristic device is said to be able to eliminate any targets at great distances, not using bullets or shells, but instead a highly focused stream of photons. Suddenly, an alert rings out over the destroyer's decks as its radar starts going wild. It can mean only one thing. An Iranian-built Houthi attack drone is hurtling toward the area at high speed, destined to wreak havoc on a nearby American bulk carrier. Yet DragonFire has other ideas. Springing to life, its turret smoothly rotates to track the incoming drone before shooting out powerful, invisible beams of high-energy light across the sky. The destroyer's crew watch in awe through their monitors as DragonFire, living up to its name, burns through the drone's outer casing with ease, frying its electronics and leaving a gaping hole in its fuselage. Completely destroyed, the drone plunges into the sea below, leaving the bulk carrier to safely continue its voyage. With more drones on the horizon, the DragonFire hasn't breathed its last. Currently under development, DragonFire is a sophisticated piece of military technology set to revolutionize the way the British Armed Forces do battle. By simulating a lasing material with electrical currents or another light source, it generates a high-energy beam of coherent light capable of accurately engaging targets the size of a coin from a distance of several miles before neutralizing them with brutal efficiency. The UK Ministry of Defence has been so impressed by DragonFire's potential that it has announced its plan to fast-track the £100 million program's development to deploy the first units by 2027. Having been officially unveiled in 2017 at the Defence and Security Equipment International Conference in London, DragonFire represents a partnership among four of the UK's leading entities in the realm of defence and technology. Missile systems company MBDA UK has provided expertise in weapon system integration. Sensor specialist Leonardo UK has contributed critical components for target acquisition and engagement. Innovative defense and security tech firm Kinetic has focused on the development of the laser technology itself, and the Defence Science and Technology Laboratory, part of the UK Ministry of Defence, has overseen the project to ensure it meets strategic defence requirements. These four organisations have aimed to offer a solution to the UK's growing need for a laser-directed energy weapon. With the proliferation of drones, missiles, and other precision-guided munitions in the modern battlefield, the British government has identified the necessity for a system that can rapidly and effectively counter these threats, particularly as its adversaries continue to innovate and deploy such technologies at a lower cost. There are many advantages to a system like DragonFire over conventional weapons. Firstly, it offers a level of precision that's difficult to achieve with traditional ballistic weapons, which may have variable trajectories and larger impact areas. This precision is facilitated by advanced targeting systems and sensors that can detect, track, and engage moving or stationary targets with high accuracy. The ability to focus the laser on pinpoint locations means that the system can eliminate threats effectively, often by disabling critical components, like the engine of a boat or the propellers of a drone, without needing to completely destroy the target. The precise nature of laser engagement also contributes to minimize collateral damage. In military terms, collateral damage refers to unintended damage or casualties inflicted on non-targets. Since lasers can be controlled to hit specific parts of a target, the risk of causing broader damage to the surrounding environment or harming non-combatants is significantly reduced. This is particularly valuable in urban or populated areas, where civilian lives might be in danger, or in complex maritime environments, where traditional explosives might cause damage to nearby vessels and infrastructure. Moreover, DragonFire is exceptionally cost-effective, with each laser shot estimated to cost as little as £10. Unlike traditional weapons that require ammunition, the primary ammunition for a laser weapon is energy, which can be supplied by the ship's power systems, reducing the logistical burden and cost associated with manufacturing, transporting, and storing ammunition. Additionally, lasers do not suffer from wear and tear in the same way as mechanical systems that launch projectiles, potentially reducing maintenance costs and increasing the longevity of the system. DragonFire has undergone several testing phases that showcase its development progress and capabilities. Initially, the trials focused on low power settings to prove the system's ability to track air and sea targets with high accuracy. These early tests were successful and led to more advanced trials involving high-power laser firings. A significant high-power test was conducted at the Ministry of Defence's Hebrides Range in Scotland, where DragonFire was fired against aerial targets for the first time, part of a broader effort to transition the technology from a research environment to practical battlefield applications. In these tests, the system has proved itself more than capable of melting a range of targets, such as drones, sheets of steel, and 120mm mortar shells. The trials demonstrated the system's ability to track and engage moving targets at long range, emphasizing its potential as a cost-effective and precise alternative to conventional defense systems. MDBA UK's managing director, Chris Allam, has said of DragonFire, quote, "It's a game changer. This is a revolutionary step in terms of capability." In the hands of the Royal Navy, DragonFire will play a key part in enhancing maritime security around the globe. In hotspots around the Middle East, such as the Strait of Hormuz and the Gulf of Aden, drone attacks have become increasingly commonplace in recent years. The Houthi movement, which currently controls the western portion of Yemen and the country's ongoing civil war, has recently been taking aim at both military vessels and commercial shipping that they consider to be linked with their adversaries. British Type 45 destroyer HMS Diamond and Type 23 frigate HMS Richmond have shot down several drones over the Gulf of Aden since late 2023. Were these ships to be armed with the DragonFire system, they would undoubtedly be able to protect maritime interests in the region even more effectively. In addition to taking out drones and missiles, DragonFire is being considered for use against small boats, which could prove effective for combating modern-day piracy off the coasts of Africa and Southeast Asia. By disabling boats or critical components on them, such as engines or navigational systems, DragonFire could help the Royal Navy enforce maritime law and secure busy shipping lanes more effectively. However, DragonFire is not only designed for use at sea. If used on land, it could prove equally valuable. Its ability to take down aerial targets with impressive accuracy may prove useful for defending military bases, power plants, communication hubs, and other vital infrastructure targets from drones, rockets, or mortar rounds. It could also play a key role in providing anti-drone security in civilian environments, such as airports, government buildings, or public events. Another potential land use for DragonFire could be along borders, especially those susceptible to smuggling or illegal crossings. DragonFire could help monitor and control movement, disabling vehicles or other equipment used in unlawful activities without resorting to lethal force, thus enhancing security while reducing the potential for escalation. Yet the UK is not the first country to develop laser-directed energy weapons. With the trailblazing use of laser technology in a military context since the 1980s, the US has been a pioneer in this field, investing significantly in various systems for both defensive and offensive applications. Since 2014, its AN/SEQ-3 laser weapon system has been installed on naval ships, while the US Army is currently developing the High-Energy Laser Tactical Vehicle Demonstrator, which aims to provide air defense against incoming threats like rockets, artillery, and mortars. Israel, another country known for its prowess in military technology, has developed the Iron Beam, a laser air defense system designed to complement its missile-based Iron Dome system. Meanwhile, China has also made substantial progress in laser weapon technology. Reports indicate that the Asian giant has developed and possibly deployed ground-based laser systems designed to intercept aerial targets, forming part of a broader strategy. At the same time, Russia claims to have developed several types of directed energy weapons, aimed primarily at anti-drone roles and electronic warfare applications, though specific operational details and deployment statuses are less transparent. Each of these country systems shares the common goal of providing precise, low-cost engagement options compared to traditional munitions, with varying focuses on air defense, maritime security, and ground-based applications. The development of these technologies indicates a significant shift towards next-generation combat systems, where speed, precision, and adaptability in different environments are crucial. With laser-directed energy weapon systems looking set to become an increasingly key component in 21st century combat, it comes as little surprise that the UK has decided to invest heavily in the DragonFire program to speed up its deployment.